This is chapter 11, and it's going to start off with the law of sines. So, without trying to understand the drawing is a single triangle that I'm trying to show you has three different possible heights. So let me do it over here, be a little bit more clear. If I had a triangle like this, here's one height right there of the triangle. Well, there's a second height. If this is the base, then that would be the height. And every triangle has three heights. If this were the base, then that would be the height. Now, it depends on the makeup of the triangle. The example is an obtuse triangle, right? It's got an obtuse angle, so it looks a little bit different. Sometimes the heights are literally outside the triangle. But if you remember from geometry, a height is always perpendicular to the base and to the opposite vertex. Perpendicular to the base and to the opposite vertex. So out of this one triangle right here, there are three possible heights. All right, so what I want to do is try to develop the formula for area, for the law of sines. All right, so area of a triangle. Base formula, area of a triangle is what? Do you remember it? Say it again. 1/2 base times height. By the way, do you still remember Heron's area formula? The square root of S times the quantity S minus A times S minus B times S minus C. And what was S? Semi-perimeter, right? The sides divided by 2, length of the sides divided by 2. Okay, oh, how soon you forget. All right, anyhow, that was just a little bit of review there. So, basic formula. Area of a triangle equals 1/2 base times the height. Okay, if you look at the main triangle, and I wouldn't draw on your drawing, although you can if you want. If we do the sine of angle A, it would be the opposite. Oops, I went too far opposite. Got to be a right triangle, right? It would be the opposite, which in this case is H1. I'm going to use red, right? It would be the opposite over the hypotenuse, and in this case is C, right? So the sine of A is the opposite of this right triangle over the hypotenuse of this right triangle, and therefore it is H1 over C. All right, the sine of A, H1 over C. Okay, let's take this thing and let's solve it, though, for H1. The height, the first height there. All right, so hopefully you agree. Things in the bottom go to the top across the equal sign. So let's switch sides, though. Would you agree that height 1 is C times the sine of A? Is that okay with everybody? Right, just comes from what we learned last chapter. The sine is the opposite over the hypotenuse. So height 1 is C times sine A. Now, you can do this with every single triangle. So what's the area of the second triangle, or the second, using the second height? 1/2 base times height 2. And I'll even do base 2. Because again, remember, the base is whatever side you choose, and therefore then the height is the perpendicular altitude from that base to the opposite vertex. And so the area of the third triangle, or not really the third triangle, but using the third height, is 1/2 base 3 times height 3. 1/3 base 3 times height 3. Okay, so in all of this, we've got in the first example, you've got the sine of A equals C, or I'm sorry, the height equals C sine A. We can do this with all three of the triangles. So let me see if I can keep from not confusing you too much. Let's take this first formula. And so we're doing the area of the triangle. The half is the half. The base is the base. But let's put this in for the height, right? So you get C sine angle A. So the area of the triangle is 1/2 base, or B, times C sine A. Now again, I don't want to get too long in all of that, but if I do the exact same thing for the other two heights, and again, you got to take your time and you got to look at the other angle. Look, if I were doing the sine of angle C, it would be the opposite H2 over now the hypotenuse B. And if I were doing the sine of angle B, it would be the opposite. And again, you got to go with, I'm sorry, angle B, the right triangle, you got to go opposite over hypotenuse. Trust me on this. Here's how the other two end up. This one ends up being 1/2 A times B sine C. And this one ends up being 1/2 C times A sine B. And again, if I had more time, I would take more time and show you on the actual using that height. But all of what I just did is the exact same thing as this using the other height. Okay. So again, if you follow all that, great. If not, you can live with it. I'm just trying to show you where the formula comes from. Okay. Because all these are equal, I'm just going to set them equal to each other. So I'm going to take all three and I'm going to use this equal sign between. So 1/2 BC sine A equals 1/2 AB sine C equals, and then the third one, 1/2 CA sine B. Just took all three and made them equal to each other. Because guess what? All the areas are equal because it's the same triangle. So let me try to recap. What did I just do? I'm figuring out the area of the triangle using all three of the possible heights. Now it's the same triangle. It's that red, green, blue-sided main triangle. The first area is using H1. You use the B as the base, and therefore H1 is a height. The second time when you go to solve the same triangle for area, you can use then side A as the base, and then its altitude and height. And the third time is using sine C as the base and its altitude or height. All right, so same thing. All right, so if you look at this, anytime you have the same thing on an equation, you can get rid of it, right? Got a half on both sides. And again, I'm using three things instead of two. You could do two at a time, but it's quicker doing three at once. Okay, so those are gone because you got the same thing on both sides of an equation, right? If you had 2x equals 2 times 7, you can get rid of the 2's. All right, half same way. And the other trick in this, and I'm doing green, what if we just divide everything by ABC? Can't you divide both sides of an equation by the same thing? So that's the trick. We're going to divide each part by ABC. Okay, so the BC divides out in the front one. And what are we left with in that first fraction? Sine A divided by A. Cross off the AB in the second one. And what are you left with? Sine C divided by side C. And cross off the A and the C in the third one. And what are you left with? Sine B over side B. That's the law of sines. That's where it comes from. Okay, and you may not have understood all that. A few of you may have. That's fine. But that is where the formula came from. That is how it's developed. And that is the idea. All right, whether you understood all that or not, doesn't matter. You can still use it. And it's pretty easy to use. And here's the thought. Use the law of sines to solve oblique triangles. O-B-L-I-Q-U-E. Use the law of sines to solve oblique triangles. What do we mean by an oblique triangle? Just a non-right triangle. Here's what's going to happen to some of you. So listen, and this is real important. When we started chapter 10, we said this is right triangle trigonometry. And when you think of the sine as the opposite over the hypotenuse, guess what? It's only for a right triangle. When you think about the secant as the hypotenuse over the adjacent, guess what? It's only for a right triangle. Hey, Ben, do me a favor, get rid of that gum. It's only for a right triangle. So what about if the triangle is not right? And I got news for you. Most triangles are not right triangles. Well, how do we deal with those situations? We've got the law of sines, and what we're going to learn tomorrow, the law of cosines. So these are for non-right triangles. Non-right triangles. What's the formula? Generally, the form is, instead of putting the sine and the angle on the top, we put the side on the top and its function on the bottom. So what's the formula? Side A divided by the sine of angle A equals side B divided by the sine of angle B equals side C divided by the sine of C. And again, I use the abbreviation in my signs. Do you use three fractions? No. You pick the two that involve the problem you're dealing with. And so, let's see, make it easy here. You know, if you're given information, depends on the information you're given, which part you're going to use. So the situation would be something like this. Maybe your equation's going to be those two, right? Because they gave you the information for the A's and the C's. Maybe you're going to use these two because they give you the information for the B's and the C's. Or maybe you're going to use these two because they gave you the information for the A's and the B's. And remember, you guys, hopefully you know this, if you got two things equal to themselves, you can either do it this way or you can flip both, right? When I developed the formula, the signs were on the top and the sides on the bottom. You could do it either way, and it's to your advantage. Whichever way is to your advantage, that's how you're going to deal with it. But that's the idea. All right, you do have to know law of sines. Look, it is quite easy. It is quite easy. So, you know, side A over sine of A, side B over sine of B, side C over side sine of C. Pretty simplistic. Let's see if we can put it to use. All right, so the first example here is when knowing two angles and a side. Some get all caught up in this angle, side, angle, all that stuff. You can if you want, but in my opinion, most people's brains, half a year or a year down the road, aren't going to remember those letters and know which one goes with which. I just simply look at the triangle and deal with the triangle that I'm given. Anyhow, this first example, you're given an angle and a second angle, and remember from geometry, a non-included side, right? If I would have said angle, side angle, then that side would be between the two angles, right? So angle, side means you have two angles and a side that's not between those two angles. That's our situation, right? Look, we've got this angle, and we've got a side that's not between the two angles. So hence the condition, angle, side. Okay, so we're going to use the law of sines to solve this thing for side A. Yeah, you know me, whenever I do a proportion, I like to put what I'm looking for in the top left. It's just the easiest way to solve the thing. So if I'm looking for side A and it goes on the top left, guess what goes on the bottom? Sine of A, right? Sine of angle A. And now I have to look and say, let's see, what did they give me? They gave me B, so I'm going to use B over sine B. Now, normally, I would just go right to the numbers right there, but just first time we're doing it, let's make sure our notes are clear of what we're doing. So we made a proportion. What we're looking for, top left. Therefore, it made the sine of angle A have to be on the bottom. Which side did they give me? They gave me side B, right? It was opposite angle B. So therefore, I put the B on the top with sine of angle B on the bottom. Remember, the A and the sine A, the B and the sine B, the C and the sine C are always an angle and its opposite side. So again, let me just be clear on this. If we're dealing with side A, it's the sine of the opposite angle that goes with it, angle A. If we're dealing with this 7, then it's the opposite angle that goes with it, angle B. You follow? You got to keep that straight. Otherwise, you'll be a mess. All right, now it's just, let's go ahead and sub in and finish this thing off. It's pretty simplistic from here. A is A. I don't know why I'm in red. No big deal. Sine of angle A, so you get the sine of 20 degrees. B is a 7. And angle B is 28 degrees. So you got A divided by sine of 20 degrees equals 7 divided by the sine of 28. And look, isn't this easy to solve? Things in the bottom go to the top across the equal sign. Wow, that's pretty easy. So calculator out. Go ahead and punch that out. Make sure that you can get your calculator to give you what you need. So punch that out. Look at your triangle and ask, does my answer make sense? Now, if you got 37,000, like some of you got the distance from Woodbridge, New Jersey to Woodbridge, Virginia. I think I did South Amboy, actually, to Woodbridge, Virginia. You got it to be 10,000 miles. Woo-hoo-hoo! Some of you got it to be 4,000 miles. Ooh la la. Does that make sense? No. All right, anyhow. So what do you got? Say it if you got it. 5.1 if you're punching correctly, right? Just make sure that you're punching things correctly. That's not too hard of a punch. 7 times the sine of 20 degrees. Divide that total by the sine of 28 degrees. And 5.1, and that answer makes sense. Listen, this is what you cannot do. So look at the triangle. This is what you can. This is what some of you will try to do on this test. Oh, angle B, the tangent of angle B, you'll try to do something like this, is 7 over A, and I can get A that way. Why can't you do that? Because it's not a right triangle. All right, you can't do that. All right, this is not a right triangle. You can't use those trig functions that way. Got to use the law of sines. Let's do another one. Okay, this one's side-side angle. You have 2 sides and the non-included angle. Side-side angle. In this case, we're going to solve for angle A. So remember, the trig function goes with the angle, so I have to have sine of A on the top. Now again, side A is going to go on the bottom, and we're algebra 2, so, all right, we got the formula in our head, so what are we going to stick on the bottom? What number? 5.1. All right, we got to look at what they gave us. So hopefully you're going to stick on the top what? Sine 28, right? And of course on the bottom you're going to put 7. And of course we know things on the bottom go to the top across the equal sign. My advice is that you put this in the front though. That's my advice. Now, one more school of thoughts. What are we looking for? A what? An angle. Which buttons on the calculator gives you the angles? The -1 buttons, right? So technically, if you wanted this to look right, you'd say the measure of angle A is sine to the -1 of this, right? 5.1 times sine of 28 degrees divided by 7. And again, you have to punch that correctly. I'm not saying you need to write that step out. I should see your proportion. Most of you would know how to punch it from there. That's fine. But technically in your notes, I would write that because that's what you got to do. All right, so punch that out. Let's get the measure of angle A. Anybody got it? 20.0 degrees. Amazing. It was the same triangle we just did a moment ago on the first example. But of course it would get that, right? It's the same triangle. I just gave you the value we found in the first example to see if we could use it to get angle A. Are you punching it correctly? Got it squared away on your buttons? Okay. So that's a side angle. Let's do an angle, side angle. Okay, so I'm 2 in. So on this next example, again, notice we have, in this one, we've got an angle, the included side, and an angle. And so in this situation, we can find z. We wouldn't be able to find this other side. That's for tomorrow, the law of cosines. Can't find that with the law of sines, but we can find it. We can find z. All right, so I'm going to do z up here, but you try to do it on your own while I'm doing it up here. If you need help, you can look up here, all right? So you go ahead and do it while I do it. Set up your proportion and go ahead and solve it and see if your answer makes sense. Did I change my notes? No, okay. There's one twist, so just keep going, and if you get stuck, you can look up for the twist. Make sure your answer makes sense. Change the letters to protect the innocent. All right, so hopefully that's what you're in. What'd you get, 11.1? So again, on this one, I had to use the 5.1. Therefore, I had to use its opposite angle, which was angle x. They didn't tell me angle x, but they did tell me the other two angles. Therefore, I know x, right? Because we know the 3 angles of a triangle equal 180. How many got that one correct? Okay. So you're setting up your proportion, and you're just solving the proportion. You got to make sure you're punching things correctly. Questions on that one? Okay. Oh, we don't have the same triangle anymore. Look at that. Okay. So same deal. And let's see, I'm gonna have to go fast here, so why don't we do these together? If they say solve the triangle, they mean I need all 3 angles, I need all 3 sides. We did this last chapter. The only difference is we don't necessarily have right triangles. Okay, I look at this situation, and I say to myself, I only know one angle. So I know 2 of the sides. I can get that third side. I'm going to call it little y, and I'm going to solve for that little y right off the bat. I'm going to make my law of sines. Take that back. Can't do that yet. We'll come back to it. This would be real life, right? Ooh. This would be real life if you were doing the problem. You would sit there and think, okay, let me go ahead and get that side first, and you say, oh, I can't get it. You know why I can't get it? Because I don't know angle y, right? The only way I'm going to find side y is if I know angle y. Okay, let me go after an angle. I can get angle z. I'll do that first. Sine of angle z over its opposite side, 15, equals the sine of angle x, which is 42 degrees, over its opposite side, which is 12. See, there's more than one way to skin the cat. And again, this would be real life, because you're just thinking through, you're just thinking, oh, I'll try y first. Nope, can't get it. Got to be something else I can get. I'll go to z. All right, move to 15. Remember, you are punching the sign to the -1 button. And where we end up on this, measure of angle z. is 56.8 degrees. Anybody concur? Okay. And so now we have 56.8. Can we now get angle Y? Can we get angle Y? 56.8. Law of sines got us there. Do I want to use the law of sines to get angle Y? No, you can't anyhow. But the three angles of a triangle equal 180. So what's 180 minus 56.8 minus 42? And that thing ends up being what? 81.2? Triangle not drawn to scale. 81.2. Now can I go back and get side Y? So are you caught up? So first off, we use the law of sines to get angle Z. Second, we could get the third angle by doing 180 minus the other two angles. And now I can get side Y by doing Y over the sine of its angle, 81.2 degrees. And I always try to use the values they give me whenever I have a choice. They gave me the 12 and they gave me the 42 degrees, so those are the ones I'm going to use. When I have a choice, I always want to use the ones they give me if it's my choice. It's safer. I know those are true values. So again, things on the bottom, go to the top across the equal sign. So you can do Y equals 12 times the sine of 81.2 and divide it by the sine of 42. You punch that out, you end up with Y being 17.7. Okay, so we ended up doing this first and this second, right? Was our order. Actually third, but that's okay. So we got that, and don't forget, we used the three angles of a triangle to get angle Y. Okay. Maybe I should have said this was second and this was third. Probably be more accurate, right? So we found the measure of angle Z first, then we found angle Y, and then we found side Y. That's going to be the situation. Now the second example is a little different in that the given information is different. If you look at the one we just did, they gave us what? Two sides and an angle. The second example, they give us two angles and a side. So what would you go after first on the bottom one? What would you go after first on the bottom one? I always go, look, if they give you two angles, why don't you go after that third angle, right? Again, it's just simplistic. 180 minus 40 minus 98. Not a whole lot involved with that. What do we end up with? What is it? 22? 42. So that sounds better. All right, 42 degrees is angle P. Now you have two things left. If we label them, this would be side G, right? Opposite angle G. And this would be side P, opposite side P. So you got to go ahead and go after either one. Is fine now because you know both opposite angles. And so again, you're going to choose, I'll go after G first. Right? So G over the sine of, don't say it yet, everybody look. Which angle goes with G? Sine of how many degrees, class? 40, right? It's opposite angle equals, what are you going to stick on the top? 30 meters, and you're going to stick the sine of its opposite angle, 96 on the bottom. 98 on the bottom. Thank you. No Kool-Aid for you. All right, move the sine 40 and solve that out. Again, you're just punching that on your calculator. 30 times sine of 40 divided by the sine of 98. And what do we end up with? Meters. Notice I put my meters in my formula so I wouldn't forget the meters. Okay. So we've gotten the angle, which was really first. We've gotten the side G, which is second. And go ahead and go after side P third. Again, if you need help, you can look up. If you know what you're doing, try to do it yourself. Again, I always try to use the values they give me because I know those are correct. So you set up your proportion, side P divided by the sine of angle P, which is 42 degrees, equals side T, 30 meters, divided by the sine of angle T, which is 98 degrees. Punch it out, and what do we get? 20.3. And we have solved the triangle. Say again? Meters. Yes. Most students don't think the law of sines is that difficult. It's not really. It's a proportion. Proportions are easy to solve. Good timing, Luke, because the more interesting thing is coming up next, all right, or last. Okay, so any questions so far? So, law of sines. Do you have to start with what you're looking for on the top left? No, but it's way easier to finish the proportion that way. It just makes it easier. Stay corresponding. Make sure you're punching the right buttons. If you're getting an angle, you got to use -1 button. Okay, so let's look at this last situation. Sometimes they're not going to give you a picture of a triangle. They're just going to give you values, at which case you have to make up the triangle. Well, here's the problem. Given two sides and an angle opposite one of them, the side-side angle scenario, it results in the possibility, or the situation some just simply call the ambiguous case. And no I before the B. Let's spell it right. Ambiguous case. ambiguous. The ambiguous case. Do you guys know when something is ambiguous, what it means? It's vague. It's not clear. You're not sure. It's ambiguous. Because here's the situation. So remember, they're not showing you a triangle. They're giving you values. They're giving you two sides and an angle. And they're not giving you the included angle. So they're giving you two sides and a non-included angle. When they do that, there are three possibilities. Possibility one. Possibility one could have either an acute angle or an obtuse angle, right? They could give you two sides and the non-included angle could be acute. That's my first one showing there. Or it could be obtuse. This is all the first situation. The green side is one of the sides they gave you, and the red side is the other side they gave you. And here's the situation. This is too short. It doesn't reach. It doesn't reach. It's a possibility they could tell you it's the value of the side, but guess what? It doesn't reach the third side. Can you have a triangle if it doesn't reach the third side? The answer is no. Same situation with an obtuse angle. It could be too short. And in that situation, no triangle exists. If you tried to calculate it in your calculator, guess what? What do you think your calculator is going to tell you? It's going to pop up and say, no such triangle exists. All right, probably in about 3 more years it will, but not yet, all right, because we haven't dumbed you down that far yet. All right. You're going to get an error, domain error, syntax error. You're going to get an error because no such triangle exists. Second possibility. It could fit just perfectly to give you a right triangle, or it could be so large that there is only one triangle. Because here's the point. If I started swinging this to move it, right, because we only know the one angle, it would miss the other side except when it's there. It's only one possibility. It's either like that or nothing, so you get only one possible triangle. So the second scenario is one triangle exists. So when you have this ambiguous case, side-side angle, you can have no triangles, you could have one triangle, or dun-da-da, you could have 2 triangles. Because here's what happens. When you swing this, if it's just the right size, it can come up and be a triangle over there. See, did the length of the green change? No. Did the angle change? No. Did the length of the red change? No. I didn't change any of those because I was given that side-side angle. So the side could come down here and hit the triangle here and make that triangle, or the side could come out in here and make that triangle, and both are valid. So guess what? 2 triangles exist. We don't know which one it is, and you got to give both. You got to give them both. You got to give them both. You got to give them both. So how does this play out? So let's do one example, and I'll try not to go too fast, but it looks like we're getting there already. Okay, how do I set these up? I always start with a horizontal line, because you have to draw the triangle. So I start with a horizontal line. I then take the side, and I'm going to take the 8, and I'm going to do what I think is about a 28-degree angle. And I'm going to go like this. And I'm going to call that 8. And now I'm going to go like this and go 7. And I'm going to go like this and go 7. Now the calculator will let us know, and it'll take care of things. So this was angle P right here. We have R and P. What do we want to call the last side? We'll call it Q. Why not? So do you see how there are 2 possible side Qs? Longer Q if it's this one, and shorter Q if it's that one. And guess what? With angle R, you could have acute angle R there, or obtuse angle R prime there. And guess what? If you got to solve this triangle, you got to find them all. Got to find them all. Got to find them all. All right, so how are we going to start this? Without me running out of time. We'll see. Trying not to go too fast. I'll go as far as I can, and we'll have to leave it. All right, first. Let's go ahead and solve for angle R. Let's go ahead and solve for angle R. And tell you what, let's put the angle measure in here. That's 28 degrees, right? That's what they told us. So first off, sine of angle R divided by the length of R. R was 8, correct? And do you see how they gave us the 28-degree angle and its opposite value of 7, right? You see that? No matter which triangle you're worried about, isn't the angle 28 and its opposite side 7? Yes? Earth to people, if you don't understand what I'm saying, See, that's half of you guys' problem. You don't know what I'm saying right now, and you just sit there with a dumb look on your face, and you don't ask. You have a 28-degree angle, and its opposite side, no matter which triangle you're looking at, is still 7. So we're able to use that relationship. Sine of 28 degrees divided by the value of 7. Now we got to solve this. Things at the bottom go to the top across the equal sign. Remember, you're punching your -1 button. When you punch this out, and you don't have time to punch it, it's 32.4 degrees. 32.4 degrees. Which of the two angles did we just find? That's the acute one, right? So we must have found that one. 34.2 degrees. 32.4, yeah, did I say 34.2? 32.4. Okay. Second, now I can get the measure of angle Q. And just to be clear, that's 180 minus the 28 we were given, minus the 32.4 we just found, right? 3 angles of a triangle are 180. So the measure of angle Q is 119.6 degrees. 119.6. Third, we got to find side Q. Go back to blue here. Side Q is over here, right? It's this side right here. Side Q over the sine of angle Q. So that's a sine of 119.6, right? What we just found. And again, I'm going to use the 2 I know. So Q over the sine of 119.6 equals the 7 over the sine of 28 degrees. Move your sine 119, and Q equals 22.2. Okay, I'm not going to have time to go past this. Your homework is your homework. You're going to have to use your book if you need to, but look here. I got to show you how to finish this off. We just found this to be 32.2, right? This now is an isosceles triangle. What is this angle? 32.2. What then is its complement? Q prime. 180 minus 32.2. That's going to allow you to figure out the new Q angle, and the law of sines will give you the new Q side. Cool. Does the ambiguous case come up all the time? Nope, every once in a blue moon, but when it does, you have to be ready for it.